grade 10. We are doing a very interesting topic, electricity. Um, Electricity, the term itself is straightforward. Electricity is it is a generation of energy that we need in our household, and we need to understand that this chapter will be done in grade 10, grade 11, and also grade 12. So whatever you learn from grade 10, you're going to use it in grade 12. So always make sure that you don't miss out. Okay, let's get right into it. What you can see on the screen is a circuit. So this is just a fundamental demonstration of electricity using a battery. Okay, electricity deals with circuits. In a circuit, you have an open circuit and a closed circuit. So when you close a circuit, as you can see, the light bulb will light up. Okay. Now, in the concept of electric circuits, we have the EMF, which is the electromotive force. Electromotive force. EMF of a battery. This is the potential difference across the battery when the circuit is open. When the circuit is open and you put a voltmeter around battery, you will get an EMF. Now, when you close the battery, there is so-called internal resistance inside the battery, which leads to the so-called loss volts. So when there's certain amount of voltage lost inside a battery, the resultant of that of the voltage that you're going to measure is what we're going to call the potential difference across the battery when the circuit is closed. Okay, as you can see on the screen, that's the EMF and the potential difference. As soon as you close the circuit, we will get the potential difference. So the EMF and the potential difference are different. Why are they different? Because there's always lost energy inside the battery due to internal resistance inside the battery. Okay, now the potential difference between the two ends of a conductor is equal to the energy transferred from electrical to other forms of energy per electric charge flowing through it. The potential difference is given by the work done by the amount of charges that have been transferred. So, because as soon as you attach the battery, there's charges that starts to move within a conductor, and the potential difference, what you're going to measure on the voltmeter, it is the energy that has been generated by the movement of those charges that have been transferred within the segment of your conductor. Okay, so V equals W divided by Q. So W is in joules and Q is in coulombs and V is in volts. A voltmeter measures the potential difference and the EMF and is connected in parallel with the resistor or the battery and has very high resistance. Okay, as you can see on the screen, This is the voltmeter. This is the voltmeter. And this is a resistor. And this is a battery. So if you want to find the potential difference of the resistor, you come and put a voltmeter there. You come and put it parallel to the resistor. Here, as you can see, this is the voltage around the battery. So you can see this is parallel to the battery, and this is parallel to the resistor as well. Okay. Now the units of voltage, as we have indicated, is volts or just V. Okay. Current is the rate of flow of charge inside the conductor. In other words, it is the amount of charges that have passed through a point in a conductor per second or over a certain period of time. So as soon as you plug the battery gives a force or energy. That's what we call it. We call it electromotive force. And that force pushes the charges inside the conductor, and the charges starts to move. So the current is the flow of charges around the conductor. It is the flow of charges around the conductor. So in other words, it is given by Q over change in time. Now the units are in ampere, and they are measured using an ammeter, and it's measured, it's always placed in series with the resistors and the battery. Usually, this is where you will find your ammeter. It will be in series with the resistors and the battery. Okay. Now we have the term resistance. This is the measure of opposition to the flow of current in an electric circuit, which results in energy conversion. So obviously, if you put something that is trying to resist the motion, there will be friction, and the friction causes cooling or it causes heating. So in a way, there will be energy or heat generated because of the resistor. And a very good example of a resistor is a light bulb. If you touch a light bulb, I guarantee you will get a little bit of a burn. Another resistor, it's a stove. A stove is a resistor connected in the circuit of your home. One of the resistors. So the resistance causes heating, and that heating produces energy that we need in our daily lives. And the units of resistance is ohm. Now, Ohm's law is the main law in electricity. So Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference applied across its ends. Now, to sum up Ohm's law, current equals voltage divided by resistance. This is Ohm's law in summary. Okay, I equals V over R. Now, there are different configurations of resistors that you will find in a circuit, because you're not only going to find one resistor in a circuit, because in real life you will be dealing with multiple resistors inside your house, there's a TV, there's lights, there's stoves, there's a TV game, there's a PlayStation, there's all sort of things. So we need to know how to calculate the voltage or the resistance or the current given different configurations. So the first configuration we have is the resistors that are in parallel. So resistors that are in parallel, first of all, they are current dividers. They divide the current. So if you have a resistors, if you have resistors that are in parallel, they divide the current. And what happened usually, as you have seen in Ohm's law, is that current equals V over R. So if I go and say V total over R total equals V1 over R1. So what I'm doing is I'm just replacing V over R into this equation. I just want to see. It's an experiment. V2 over R2. I'm just replacing. So I2 will be V2 over R2. I don't know if you agree. And I3 will be this will be plus V3 over R, R 3 over R3. Okay. Now we are also told that 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3. The other thing that we must know is that the potential difference everywhere is the same. So given that V total equals V1 also equals to V2 also equals to V3 according to the principles. If I go back to this equation, I don't know if you guys agree. If I change V1 to VT, change it to VT, change it to VT. If I divide both sides, I can actually eliminate VT, cancel all of them, and be left with 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. So I just wanted to show you guys where does the second equation come from instead of just cramming. Okay, now resistors in series is the opposite. They are potential dividers, meaning V total equals V1 plus V2 plus V3. According to Ohm's law, this is Ohm's law. According to Ohm's law, V equals IR. Okay, now we are just told that R total equals R1 plus R2 plus R3. So these are resistors that are connected in series. Now, the other important thing to know is that the current everywhere is the same. The current through the resistors that are in series is the same. So if it is the same, let's check. Okay, I think you will agree with me. If I replace V by IR, I will have I total R total equals I1 R1 plus I2 R2 plus I3 R3. So given that we have been told that I total is the same as I1 and I2 and I3, so I can come and make all these I's IT, IT, I total, I total. So if I have I totals, I can cancel all of them out of the equation. So I will be left with R total equals R1 plus R2 plus R3. So this is where the equation came from. So I want you guys to remember that the resistors in parallel are current dividers and the resistors in series are potential dividers. Resistors in parallel, current divider, resistors in series, potential difference or potential divider. Now, this is what you will get. So the best analogy to understand is to use the flow of water inside the pipes. If you want to understand currents and resistance, so let's say there's water that you are pumping or you are giving a force onto using your motive force, your EMF. If you're giving the water inside the pipe a certain force, it will flow and circulate. So when it gets to point 1, it will turn left. It will turn right. Sorry. Then when it gets to point 2, the flow of water will be divided. It will be divided. Some water will go through R1 and some will flow and go towards R3 and the others will go towards R2. So the other thing that you must know is that the bigger the conduit or the bigger your pipe section will be, the much easier the water will flow into that pipe. The much easier the water will flow into that pipe. So if this pipe was a bit bigger, it means the flow or the amount of I or the amount of current going through this resistor would be higher. So let's say if this one it's a bit thinner than R1, it means there'll be higher resistance. There will be less water going through it. There will be less water going through it. Meaning the larger the diameter of your conductor, the less the resistance. If they ask you that question, you must just know, you must just use that analogy. However, the potential difference between 0.2 and 0.7 is the same as the potential difference between 6 and 3. Again, it is the same potential difference between 0.5 and 4. Okay. The other thing that you must note is that the current flow from positive to negative. Okay. Now, the other thing that you must note is that V equals IR. So if your current is larger, it means your resistance will be a bit smaller. Means if the diameter of your pipe is larger, there will be a higher flow. However, when you multiply the two products, I and R, you get the same V throughout. The same V that you get from these 2 points is the same as that one. Also the same as that one. But the difference will be the currents, the current and the resistance, and that's it. The difference will be the currents and the resistance. The potential difference does not change. The potential difference on a parallel system does not change. The potential difference in a parallel system does not change. What changes or what is divided is the current. The current is divided, the flow is divided. If you use the analogy of water going into the pipes, you will understand that if you have a lot of water coming through here, some will go through this pipe and some will go through the other section of the pipe. Okay. The other thing that you must note as well, now we have a series connection. So what you must know is that if you put an ammeter there, it will be the same. If it will give you the same value as the ammeter that you put, if you put an ammeter this side, and also if you put an ammeter there, or if you put an ammeter there, you'll get the same current reading. So this is the second connection where the resistors are in series. The resistors are in series. They are following each other. The other one is following the other. The other one is following the other. This is a series connection. This is a series connection. So what you must know about series connection is that it is a potential difference divider. It means if you put a voltmeter there and a voltmeter there and another one there, because remember your voltmeters must be put parallel to your resistor in order to measure the voltage across the 2 points. The 2 points that are on the either side of the resistor as the potential difference. Okay. Now, the potential difference across all these resistors will be different, meaning it will be divided. It will be divided. Now, the total EMF, the total EMF across this battery, or let me say the total potential difference across this battery, this one, it will be the potential difference across resistor 1, resistor 2, and resistor 3. As you can see, V1, V2, and V3. If you want to find the total potential difference across the battery, you must just add the potential difference on all the resistors. I repeat, resistors in series divides the potential difference. So the total potential difference is given by V1, V2, V3, meaning you have to calculate the potential difference across all the resistors and add them. However, in parallel, you will be dividing current, meaning the total current, say at this point, if you put an ammeter there, the total current will be the current at resistor 1 plus the current at resistor 2 plus the current at resistor 3. That's how it is. So that's all for today. Is the end of the segment. I'll see you on the next one. Thank you.